right, and welcome to Unit 2 of Pre-Calc. Congratulations, the first unit is under your belt. Okay, we're moving on to Unit 2. Wow, it's very exciting. You're going to find that throughout the year that Mrs. Logos and myself will kind of alternate units for videos. Okay, so I'm in charge of Unit 2. Okay, so you'll get to see my face a lot this unit, so too bad, so sad. I feel bad for you guys. Maybe I'll take my face off of that for a little bit. Okay. All right. So today we're going to introduce functions and definitions. Our learning targets of the day are to understand function notation and to, talking about the vertical line test and the difference between a function and a relation. Okay. So let's dive right in. A relation, as you'll look on your notes, it's written out for you. It's typed up for you. How nice. A relation is any graph or equation relating two variables. Okay. Usually x and y. So it's any graph or equation relating those two variables. A function is a specific relation that talks about one domain value, okay, which is usually our x, and assigns that to one, exactly one, that's a key word, one range value, which is usually a y value. Okay, now it can be a y, it can be f of x, it can be an output. Again, our domain value can be x or it can be an input. Okay, so in order for a relation to be a function, okay, you can only have one input for every output. Okay, one input for every output. All right, so a function, one input, excuse me, that one input can only have one output. Now, two different inputs can be assigned to the same output, though. That's okay. Okay. So functions are noted with f of x, g of x, h of x, etc. It's just the same thing as writing y. F of x equals x is the same as y equals x. Okay, that's what that is saying. Function notation is a notation you're going to have to get used to. All right, it's something that you're going to see throughout this year and throughout your mathematical careers here at the high school or in the future. Okay, so let's dive in. Which of the following will represent a function? So what I want you to do is, or excuse me, what we're going to do is we're going to draw a line from our inputs to our outputs and determine whether or not each of these A or B represent a function. All right, so here we go. This first dot, let's go. Well, okay, that first dot. All right, that's going to make some people mad, so I'm sorry if it's not perfect. Here we go. All right, that's going to bother me now. Oh my gosh. Wow. Let's bring it back that way. Missed it. Okay, there we go. All right. Struggle is real today. The struggle is real. There we go. Boom. Let's go to that one. Boom. Wow, what is that? Okay, and let's go to this one, to that one. Okay. So now we have this one dot sort of left over in no man's land without an input. So what we're going to have to do, why don't we just take this one here and draw it to that dot as well. Uh-oh. All right. Well, does this represent a function? Does part A represent a function? For every input, does it have exactly one output? And the answer to that is no, it does not, right? Because of this relation right there. Okay, because this input has two outputs, this would not be considered a function, it would just be considered a relation. So this would be a no. Wow, let's get that as a marker, please. That would be a no. All right, so let's try the next one. Boom, 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 and I'll just draw this one for that as well. All right, would this be a function? Well, your student brains are working now. You're probably going to say, well, you wouldn't put in both that don't work. There's probably going to be one that works, and you're right. This one works because each of these inputs has an output. Okay, each of these inputs has an output. But now you can see here that these two inputs go to the same output, but that is all right. That is okay. All right, our outputs or our y values can repeat. Our x values cannot. Okay, our x values cannot. So this would be a yes. That would be a yes. This one would work. All right. Let's evaluate the function given the input. So it says f of x equals, I'm given this function f of x equals x squared minus 1. I want to find f of negative 2, I want to find f of 0 and f of 1. Well, f of negative 2 is simply, instead of x here, I have negative 2. So all I'm going to do is substitute that negative 2 in for my x value. Wherever I see an x, I write negative 2. So it becomes negative 2 squared minus 1. Order of operation says square the negative 2 first and then subtract the 1. Now, if you're going to put this in your calculator, a negative number, when squaring a negative number, you must make sure that your negative number is in parentheses. Otherwise, the calculator will square the number and then multiply it by negative 1. It doesn't actually realize, the calculator looks at it as negative 1 times 2 squared, when really it should be negative 2 quantity squared. All right, so make sure not to make that mistake. I'm sure some of us will, so let's go 4 minus 1 gives me 3. All right, same thing. 0 squared minus 1, 0 squared is 0, minus 1 gives you negative 1. Last one, 1 squared minus 1, 1 minus 1 is 0. Okay, there you go. That's evaluating a function. All right, now we just did this. Okay, these are the same values, negative 2, 0, 1. All right, so that I can go down the line. This was what, 3, negative 1, 0. So 3, negative 1, 0. Now what this is, negative 2 is my input, 3 is my output. Okay, well, what's another? I substitute negative 2 in for what variable? In for x. So negative 2 is my x value, and that makes 3 my y value. These can all be written as ordered pairs. 0, negative 1, and 1, comma, 0. An input versus an output, it can be thought of as ordered pairs. I input my x, I spit out my output, which is my y. Okay, so let's plot these points now. See what this graph looks like. Negative 2, 1, 2, 3. There. Okay, come on, dude. There you go. 0, negative 1, and 1, 0. So knowing what we know about parabolas, all right? Parabola is a nice little U shape, okay? So I'm going to, that's bad, but we're just going to go with it, okay? We're just going to go with it. It does go through the dot. Look, see, it's connected. It does go through this dot, look. All right, so there's this test out there, all right? It's called the vertical line test, okay? And what the vertical line test does, it checks to see if an actual graph is a function or represents a function. So if I slide this vertical line, you can use your pencil or pen across this graph, does it hit my graph once for every single point? Yes, it does. This would be a vertical, this would pass the vertical line test, therefore this would represent a function. It only hits my line once, and you'll see a time where I might hit it twice. So what I want you to do here, I'm sure you've seen this, heard of, and or completed the vertical line test multiple times before in your previous math class. So what I want you to do here is go through A, B, C, and D and test to see which function actually which relation, which graph represents a function. Go ahead and pause and do that. All right, so here we go. Let's try these. Okay, vertical line test. A. Does blue meet? Is it like a purple? It could be a purple. How many times? So if you look at this cubic function, this graph of a cubic, it passes the vertical line test. Blue only meets purple once, no matter where I slide it. All right, so this would be check. Okay, let's go on to B. This one's a little bit weird. It looks like, boom, it hits it twice. It looks like it hitting it twice there. It looks like it's hitting it twice there. So what's really happening here? Well, if you look closely at these dots, all right, the top one is closed, okay, and the bottom one is open. So if you remember back to Unit 1, we talked about interval notation. We talked about number lines, okay? Remember that the difference between a closed circle and an open circle when graphing inequalities on a number line. Remember, the closed circle meant equal to, and an open circle meant not equal to. Well, if you think about this, that means, oh boy, that means here our function is equal to -4. Here our function does not equal -4. It actually equals -3 up here. So as I move along here, not -3, but -2. This is a function. This would represent a function. This is called the greatest integer function, or people call it the step function as well, because it looks like a bunch of steps going on. All right, let's look down at this one, letter C. All right, how many times does blue meet green? 1, 1, 1, 1, 1, 1, 1. Again, it looks like twice, but this is similar to letter B in that the top point, all right, this top point is closed and the bottom is open. So that means this would be considered a function. Again, using your student brains here, we got 3 functions. Well, this one is probably not going to be a function, and you're right. Okay, boom, hits it. Boom, 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 boom. All right, it does not pass the vertical line test, so therefore this is not a function. Now, the vertical line test only has to fail once for something not to be considered a function. I realize that in this particular picture, it hits it everywhere, but it only has to hit it. It only has to happen once. So, if for example, if this were our function, okay, well, that hits it more than once, but look, it doesn't hit it exactly. Excuse me. It hits our vertical line a couple times, but it's not consistent throughout the whole thing. If I were just looking at this piece of the function, it would be. If I were looking at this piece of the graph, yeah. But this portion right here, boom, makes it not a function. All right? So that is the end of function notation and the vertical line test, function versus relation. 2.1 notes in the books.